Hello and welcome to this session. My name is Mark Schnesk. I'm Senior Application Engineer with Seiler Design Solutions. I'll be joined in the second half of this presentation by Tom Crone, Applied Geospatial Professional Manager with Seiler Geospatial. And the working title has been changed around. It's called Situational Awareness GIS Workflows with ESRI and Autodesk. Now, since 2017, ESRI and Autodesk have partnered together. Their functionality present before this time was there, but isn't as robust as it is today. There's now live integration between ArcGIS and Autodesk AEC tools, including Autodesk Civil 3D and Autodesk InfraWorks, as well as Map 3D. Connected data publish changes back and forth, and up-to-date GIS data as a result. A couple definitions. BIM. I know this has been gone around for a while, but just to reiterate, BIM is Building Information Modeling, foundation of digital transportation, creation, and management of information, integrating multidisciplinary data across the life cycle of a project from its concept, planning, design, construction, operation, maintenance, as-built, and it's cloud-based, single source model for all disciplines. And this includes not only architectural projects and vertical products like Revit, but Civil 3D design collaboration in the Autodesk Construction Cloud. On the other side of the coin is GIS, Geographic Information Systems. Lets you store, manipulate, analyze, and present geographical data. Data associated with spatial characteristics. This will be, you can theme a model by its variety of attributes, color code. You'll see attributed data, the what an object is, including additional information besides just its location and space and object type, as well as where, and understanding the relationships, patterns, and trends between places and things to be able to analyze the data. Now, in this first half of the session, we're going to talk about the variety of ways that we can coordinate GIS and BIM data in a Civil 3D design using a variety of workflows. And the first thing we're going to start with is the Civil 3D GIS workflow options, which also includes Map 3D, as Civil 3D is built on the backbone of both AutoCAD and Map 3D. We can talk about just connecting to GIS data via the Map 3D feature layer connections. We'll also talk about importing data into Civil 3D as Civil 3D objects and also being able to export that data via the Autodesk connector to ArcGIS Online to be able to share that data out to groups or the public. We'll talk about design collaboration for Civil 3D integrations with ArcGIS Pro, and we'll also discuss GeoBIM. The first thing we're going to talk about is Autodesk Map 3D, being able to bring data in. It is an AutoCAD vertical GIS platform, directly able to access spatial data via an FDO connection. And this includes things like File Geodatabase or SQLite, SQL connections or Oracle connections, as well as regular ESRI shapefiles and Autodesk SDF files. To be able to connect to that data, present it, modify it, do some planning, do some analysis right within the Autodesk sphere. When working with GIS data and existing project data, we have a variety of ways we can tie into different sources to pull that data in. One is the use of a featured data object connection with Map 3D. I'm in Civil 3D here, but since Map 3D is a part of Civil 3D, all I need to do is change my workspace to planning and analysis, and I have all the availability of the Map 3D tools. I'll just double check. There's my task pane in there, and I can make a simple FDO connection. I know I have some GIS watermain available to me, so I'm going to go ahead and connect to that data. I have a variety of data sources I can supply. I'm going to add, in this case, an ESRI shape connection and browse for that shape file. I'm going to find this on my desktop. Within my folder, there's the shape file that I've been given that has site water main data from maybe a water utility or other source. I can connect to that, and say add to my map. My coordinate system is assigned to the GIS data. I also have a coordinate system assigned to my project so that when I add that data to my map, the data then shows up in my drawing. Let me double click, and there you can see. So this is what's called a feature data connection. This is an ESRI, a Map 3D map feature. I can stylize it a variety of ways. I can come here and do some analysis on it, maybe get some feature buffer data, create additional data, overlay it with additional data, another water main maybe from a different source, find the overlay intersections. I can theme it. I can theme it by pipe size. Depending on the data type, I can apply some other analyses to it. Another way to bring the data in is through the ArcGIS, the Autodesk connector for ArcGIS Online, which I will do next. Next, we'll talk about Civil 3D integrations with ArcGIS Online. We'll be able to connect to that same data as we showed in Map 3D with the Autodesk connector for ArcGIS Online and bring that in as civil objects. We'll be able to add that civil object data directly to our design as either points, features, alignments, or even gravity pipe networks at this time. We will be able to see the attribute data that's associated with this GIS data and be able to export and upload our civil design changes back to ArcGIS Online for use elsewhere. Here we have our Civil 3D model. I am back in the Civil 3D in a workspace, and now I'm going to make a data connection to an ArcGIS Online source. So ESRI and Autodesk have partnered together. In our Insert tab, we now make available Autodesk connector for ArcGIS Online. This can also be an enterprise server. So if you're not using the public data or using ArcGIS Online, and you have a situation where you have an enterprise ArcGIS enterprise server with a web connection, I can tie into that as well very easily. In this case, I'm going to connect to that data. It's going to bring up a map. I'm going to zoom to my site of interest in my project. I have this data organized either in my content or by group or organizational content. I've got site water main. This is the same as that shapefile data I had locally. And I can say, select this. I can view it, say that, yes, this matches the data I need to see within the area of interest. And then I can bring this data in either as an alignment, Kogo point, feature line, or if this is gravity sewer with the right attributed data, I can bring it in as gravity pipe network. As this is water main, I am prompting it to come in as a feature line, which I can then convert into a 3D pipe network as I do my design. So I'm going to click that, highlight it, all the errors are gone. I'll add this to my design project. It reads the data in, and there is that feature line. So now I have that in as a Civil 3D CAD object. And more importantly too, once this comes in, if I come to the Properties tab, go to my extended data, you can see that all the attribute data that was associated with that GIS data is also available for me to reference. I can then export this out as a property set. I can use this within Civil 3D to label those objects with Civil 3D object labels. Once we're done with our design, or during design, we can also be collaborating within the cloud. Now, this is not quite GIS based as yet, but the Autodesk Construction Cloud Design Collaboration lets multi-users work on the same projects from remote locations, being able to tie into that data, reference and data shortcut civil object data across the board. Utilize the power of Autodesk Construction Cloud and Design Collaboration. We can review the design, add markups, issues, assign those tasks to other users, and keep track of them. We can also share these views and details with stakeholders in a web environment. Design collaboration for Civil 3D let multiple project members work on the same set of drawings over a cloud-based environment. In this case, a third program called the Autodesk Desktop Connector acts as a mediator between your Civil 3D environment on your desktop and the cloud storage on Autodesk Docs. I can also set up data shortcuts with Design Collaborate Pro. so that everybody has an opportunity to get the data they need for their portion of the project. It also locks drawings so that only one team member can work on a drawing at a time, even though they can see those drawings and reference those drawings in. On the web side of things, we'll use the document management portion of the site to keep track of our drawings. Create a file structure and a folder structure that makes sense to our project, mirroring what we would have on our project servers. As a drawing is open, you can easily see the lock symbol, who has the drawing locked, and there's versioning available as well. For each project saved, a number of versions can be kept for previous versions, and comparisons can even be made between multiple versions in the cloud software. On the Civil 3D side of things, we will see that same representation of that document folder structure every time we go to open up a drawing. So the two are tied together. I'm working off a local cached copy of the drawing on my hard drive, but every time I save, it then uploads and updates itself, including any references needed, to the cloud. Other members would get that notification and that synchronization process would begin, similar as if I was working locally. On the cloud-based side of things, anybody who's a project member who doesn't have the program to look at it can still open up these drawings and projects through the viewer on BIM 360 or on Autodesk Construction Cloud. I can easily switch between 3D and 2D views, look at the data that's presented. As I select data or move data around, I can get property information from it. We go back to my 2D view. So as I select an object like the water main I brought in, or the background, you can see this is an XREF. Here is a feature line, look at properties on that, get all the information I need to, turn on and off layers as need be, create markups that can be then tied back to a user, as well as issues. Issues are items that can be created to further refine design during the checking process to identify issues, problems, or items that need to be looked at. They could then be answered by the person they've been assigned to, gone back to the original issuer, and marked as completed as necessary. The Autodesk Construction Cloud and the Workspace would also allow us to tie this data into GIS models within ArcGIS Pro. With the Autodesk Construction Cloud comes the ability for ArcGIS Pro to be able to connect to a BIM connection. So we can tie in and gain access and give access to ArcGIS Pro as well as the ArcGIS Cloud connection to our design collaboration projects within the ACC. This means be able to directly connect to the Construction Cloud, attach geospatial information data directly to your ArcGIS Pro map or scene, publish scene packages to ArcGIS Online for use with GeoBIM. Published data from Civil 3D to the Autodesk Construction Cloud can be accessed in ArcGIS Pro. When starting a new scene, just insert, create a new connection to BIM Cloud Connection. This will go ahead and create a connection. As I browse in, I can see all my projects on BIM 360 or the Autodesk Construction Cloud. I can dive into my particular project, gather the data I need, and drop it into my scene. Once the data is gathered, I've copied into my local folder. I could then go in and any of the objects that are in that Civil 3D WG can be dragged and dropped inside my map. If I wanted to see the pipe network, I can just come here to Gravity Network, drag and drop that scene in. It will add it as a layer into my scene. I can then manipulate it, do joins, do any other kind of data analysis, and publish this data out to ArcGIS Online. In addition, solid CAD data can be imported in as multi-patch data. This can include surface solids, building solids, additional types of objects. Once in here, they can be filtered out, stylized, export it as a geospatial layer, and finally export it out as a scene layer. These can then be uploaded directly to ArcGIS Online, and a scene map can be created. Simply go to your ArcGIS Online account, add new item, browse for any of your scene layers that you have created, upload it, and create a hosted scene layer. We'll then use these to go ahead and add them to the GeoBIM application. Once the scene is complete, you can open the scene in the scene viewer and see our solid building or other CAD data from our design in the ArcGIS Cloud scene environment. Next, we're going to talk about GeoBIM. So what is GeoBIM? GeoBIM bridges the gap. It's a visualization and evaluation of project data in a web-based environment. And we can share this out. We do not even have to have members have a subscription to the product. We can create public scenes, share them out. AEC teams will seamlessly collaborate and manage risk, cost, timelines, being able to dig into this combination geospatial and design data within their projects. The benefits will be able to see the projects and assets in context with other geospatial data, keep projects organized in a single user interface, reducing model conversions, be able to communicate project performance like issues, completion, timelines, asset locations, as well as do issue coordination. Take advantage of a unified web environment for issue mapping and management, and document review, connecting document to relevant ArcGIS features for more efficient and secure access to the latest project updates. ArcGIS GeoBIM lets us put our geospatial and our design data in one single portal. We can create new projects, I'll call this one Project 1. You can add a thumbnail or other information. Then we'll go ahead and tie this account with our Autodesk Construction Cloud account. Just simply create new, link to a specific project, and click OK. This GeoBIM project will now be tied to that particular Autodesk Construction Cloud account. Then under Tools, I can go ahead and have it extract engineering documents, locate issues that are on the Construction Cloud, and create BIM project boundaries that I can use for my maps in this application. It does take some time to run, so we just have to be patient and we can continue forward. Once the data has been accessed and indexed, I can then select the data, create data links between this particular item and other items within my construct, so that when I go ahead and create my apps and my scenes, I'll be able to pull from a variety of information on the Construction Cloud. Then I can edit my scene, change the format, change the type of items that I'd like to add to my list, search, full screen mode, change the layout of the tools, change highlight colors, set up the scene as I'd like it to be portrayed. Add an image header. Once saved, I can go ahead and test my app and look at the scene as if the link was sent out to me. Once the data is available, I should be able to click on the object, see any of the attributed data that's associated, plus play the linked document in an Autodesk Forge environment. Change my document browser, use it as if I was in the Autodesk Construction Cloud. and see my project come to life. Switch between the two, see the GIS data in one window, the construction data in the next. We can also isolate and create issues maps, where we can see our issues as we showed in the Autodesk Construction Cloud. As we highlight each type, it will highlight here in the map, select the issue, see the linked documents that were linked to it, and continue on to see those issue details. After construction is complete, we can go ahead and once again use the Autodesk connector for ArcGIS to tie into as-built data that's collected in the field. In the second half of this presentation, Tom Crone is going to show you how he collected that data to upload to the site. For right now, I'm going to connect to the Autodesk connector for ArcGIS Online, highlight my project area. In this sense, it's tied into the group under As-Built BIM. I could choose the objects I want to bring in, and I must remember to tie and change the type of object I want to bring that in as. Focal points, feature lines, alignments. Go ahead and add those to my project. It'll take a second for it to read the data, download it from ArcGIS Online, bring it into my drawing. And then as I regen my drawing, you'll see the data appear. And I hope that helped. So that is how you can use GIS data with Civil 3D, Map 3D, the Autodesk Construction Cloud. Take your designs, add it to ArcGIS Online using ArcGIS Pro to create your features, tie directly into either your drawing data locally or to the Autodesk Construction Cloud, upload it to ArcGIS Online, and then turn it into a GeoBIM project, which then you can ship out to other stakeholders so they have one source where they can view data. With that, I will complete my section. I will turn this over to Tom Crone, who will show you how the data was collected in the field for the as-built, how that was uploaded to ArcGIS Online and connected to the Autodesk Construction Cloud. Take it away.
As we have seen, one of the many benefits of using the Autodesk and ESRI collaboration connection is that we now have the ability to streamline data sharing between CAD and GIS through integrations. One of those connection methods includes the ArcGIS connector, where I can consume CAD data in my ESRI field and office applications, and likewise view live GIS data in AutoCAD. The power of these connections is the ability to share data in real time between CAD and GIS. And more than ever, GIS is becoming an integral in the construction field data collection operations and project deliverable requirements. For example, most local governments, municipalities, and county entities maintain their assets in GIS, and often an asset management enterprise solution. As-built data needs to go into CAD for final deliverable. But the local government entity, more than ever, is also requesting that this data be delivered in GIS format so they can update their authoritative GIS database. Now, with the ArcGIS connector, we can consume live data in the field using our ESRI mobile applications such as ArcGIS Field Maps. We can collect as-built data while construction is happening in open trench while pipe is being laid, and right on top of the design data. So we can reference in the design or preliminary data in our field applications. When we're taking the as-built data, this can be consumed in Autodesk with a real-time live connection. We will take a look at this process. Continuing with the project that Mark has explained, we will now have a look at how ESRI and Autodesk connection can streamline data sharing within an organization during construction. We will connect to the design CAD file and bring that data into an ESRI field application. So the design data so that design data can be available on a phone or tablet in the field during construction, and the RE can collect as-built data using ESRI field applications with high-accuracy GPS. In this example, we will collect water utilities as they are being installed at the construction site. A quick overview of the tools that we are going to be using in this example. We will be utilizing ArcGIS Online. We can build our as-built data collection template and store the database in ESRI's hosted cloud storage solution. This is also where we'll deploy the field or mobile applications and perhaps create an office map or two. ArcGIS Pro is ESRI's desktop software. This software gives us the ability to directly connect and edit data stored in ArcGIS Online, but it also allows us to create a connection to my GeoBIM project. Through this connection, I can access the latest CAD data and use this in my desktop or mobile apps. If a change is made to the design files, I can quickly update this through ArcGIS Pro and deploy it to my field maps. ArcGIS Field Maps application is installed on either an iOS or Android device, whether it be your phone, tablet, or a dedicated handheld device. This is where I will be collecting my as-built data in the field using my phone in this case. We'll also talk about GNSS devices or GPS devices. One example is the Trimble Catalyst or the DA2. I can use any GNSS devices compatible with iOS or Android and ESRI field maps. The DA2 presents a unique opportunity for large-scale deployment. We will brush over this later. And finally, we're going to use the Autodesk connector for ArcGIS, where I can view and update data that is being collected and updated in all of these applications in real time. We'll take a look at a live demo of all of these applications working together. Let's take a look at a project example where I'm going to collect as-built field data while construction is happening. To do this, I'm going to reference in the design file into ArcGIS Pro, and I'm going to publish that data to ArcGIS Online or ESRI's cloud service with my as-built template. After the data is deployed, I'm going to configure my field map application in ArcGIS Online. Then we will collect some as-built data. And then finally, we'll connect to ArcGIS Online inside of Autodesk to view the as-built data. To do this, I'll first go into ArcGIS Pro, into my catalog, and I will connect to BIM Cloud Connections. This is a connection setting within ArcGIS Pro where I can sign in to my BIM 360 account. Once I sign into that account, I have access to all project files inside of BIM 360. I navigate to my drawing file that contains my design, and I simply download this project to a folder. After I do that, I have access to the design file in ArcGIS Pro. I will reference in my as-built template, and I will deploy this to ArcGIS Online using my Share Web Layer and Publish Web Layer tool. Once the data is published to ArcGIS Online, I can then bring this into a field map using my map viewer. I'm going to save this project, create my symbology, any of the labeling that I have. I've referenced in external parcel data. I bring in all the layers together and I save this web map. Once the web map is saved, I can open this web map inside of my field maps editor, and I can start to configure the pop-up window. If I want to write in some automation inside of field maps, I can do this through the field map application. For example, I want to, when I put a meter a water meter on the map, I want to grab the address from the parcel data and plug it into my address field inside the meter. Perhaps my meters are tied to a water billing system, and I need to grab the exact address from the parcel layer and bring it into field maps. I can do this through automation. This is a brand new feature inside of field maps. It was available this year in the spring of 2022, and I can do this through calculated expressions. I can write Arcade to go grab data from one layer and populate the layer that I'm using. We'll see how that works when we collect a meter in the field. So now that my field map is created, let's take the data out to the field and collect the as-built data. Once my field map has been created in ArcGIS Online, I can now access that map through my Field Maps application on my Android or iOS device. In this case, I will use an iPad using the ESRI Field Maps application. I will launch that application. I am able to view all of my maps inside of my organization. I'm going to open up my as-built field map. And as you can see, I now have access to the parcel data and the design CAD file in my field map. I can change the base map inside of ESRI Field Maps to an aerial, or any of ESRI's base map options. To collect data in ESRI Field Maps, I'm going to connect Field Maps and my iPad to a high-accuracy GPS device. Once I'm connected, I can get down to the accuracy spec of the device. When I'm ready to take a shot, I will hit the plus button in the bottom right-hand corner of the screen. I'm going to drop in a couple of valves and perhaps draw in some mains on top of this map. So if I would want to collect a valve in field maps, I would zoom into my location and I would use my GPS device to navigate to the valve. I would level up, would tap the plus sign in the bottom right-hand corner. Here, I have a list of layers that are available for me to collect. I'm going to choose a system valve. I'm going to level up on top of my valve, choose system valve, and it will drop the point in on the map at my location. I can now fill out attributes. Automation I put into field maps is the project number. In this case, I want to assign a project number to every feature that is being put in using field maps. Instead of burdening the field worker with doing that, I can simply automate field maps to populate that number automatically. So project number is in, and I'm going to fill out the valve type and the stage and any other attribute deemed necessary for the project. Hit submit, and the data is now on the map and in ArcGIS Online. I'm going to navigate to my next point, GPS point. Let's say the utility required me to take pipe shots at every 10-foot or 20-foot interval. I can add a water pipe points layer to my as-built data. It'll drop a pipe shot on the map, and now I can fill out the information. I now have a location of that pipe point. I'm going to continue on and perhaps put in a fitting where our service is going to connect. And then finally, I'll put in another valve for demonstration purpose at the end of this pipe run. I now have my points that I've taken out in the field. Now, I can turn off any layers. I'm going to change my base map back to my street map. And I can turn on and off any layers through my table of contents. In this case, I'm going to turn off my design. And now I'm left with my parcels as well as the new points that I put on the map. Now, to connect those points with a water main, ideally we would do this in ArcGIS Pro or inside of my Autodesk. However, for the purpose of demonstration, I want to show some drawing features that are available inside of field maps. There is a case for using this. I'm going to draw in water main and connect these points using drawing tools inside of field maps. So to do that, I'm going to hit my plus sign and I'm going to put in new water main. Now, one of the nice features and a fairly new feature of field maps is the ability to snap to points. As you can see, as I hover over any one of my points, I can see that snapping has been engaged. I'm going to hover over my first valve and drop a point on that valve. I'm going to move my cursor, snap to this water point, and I'm going to add a point. And as you can see here, I'm adding my water main using drawing tools inside of field maps. I'll fill out the material, pipe size, and I can even automate field maps to do some math behind the scenes. I have a price book inside of field maps of linear foot material costs. I am calculating the measured length using arcade expressions. This is a 259 foot pipe, and I can put in a price book of what type of pipe that I've added to this map. So if this is 4-inch main, I can start to run calculations of measured length times the linear foot of 4-inch main and give a costing to this. You can see if I change this, the math changes on my subtotal. Here I'm going to put 4-inch main, hit submit, and now I have all of my shots on my structures as well as the water main. Let's take a look at how this data interacts with ArcGIS Pro. If I launch ArcGIS Pro, I can now reference in the as-built data that I took in the field. I am connected to the very same feature service that's being used in field maps, and thus, as data is being collected in the field, I can see that data come in to ArcGIS Pro. As such, I can also connect web maps or ESRI dashboards to the same data and my Map 3D or Civil 3D AutoCAD. So if I come into Map 3D, I can connect to that feature service in the cloud. You can see here, I have the two valves that I took at either end of this pipe run and that water main that I just drew in ESRI field maps. Here's the new water main as well as the valve. To make this connection in Map 3D, I have a tool called the Autodesk connector for ArcGIS. If I access that tool, it will ask me where I want to connect to data. I'm going to zoom in to my project area. And I'm going to tell the connector for ArcGIS to look for data inside of this box or my project area. I can go to my content, which is all of my data inside of ArcGIS Online. And for this case, I want to pull my as-built data and all of the layers in my as-built data. I select all of these and I add these to my design project. Once that has been completed, I now have a live connection to my ESRI hosted feature service. Let's take a look at how this works if I add in a new service line in ESRI Field Maps. Okay, let's drop a point in Field Maps. We'll put a hydrant in and a meter location and see how those come into our Map 3D in real time. So I'm going to drop in a hydrant location. Here's the design file. And say we install the hydrant, right? I can fill out the information and submit that point. And then I'm going to put in a meter point as well. Now, as we saw earlier, we did write in a little bit of automation in Field Maps to populate the meter address with the address of the parcel. This is a spatial query. What it's doing is when I put in a meter, it's going to go underneath that meter to the parcel polygon and grab the address and bring it into the meter attribute. In other words, I'm on 104 Dundee Avenue here, as we can see on my screen. If I were to drop in a meter, if I hover over that parcel, 104 Dundee Avenue, and I put a meter in, take a look at my address. It is populated with 104 Dundee Avenue. This is spatial query and join. It's grabbing the data from the parcel and populating the meter address. If I come over to 803 Bruce Court and update that point, it will populate the address. So here, I'm going to drop our meter location in. Hit submit, and we'll take a look at how that comes into our Autodesk. I am now in Map 3D and referencing both my design file and again, my ArcGIS online hosted feature services. This is a live connection to ArcGIS Online. I'm going to refresh my meter layer as I want to view that meter that I just dropped in ESRI Field Maps. If I hover down to that meter location, and if I hover on top of it, I can see here's my new meter location. 104 Dundee Avenue, meter ID number 3. So if we're going to be collecting as-built data in the field while construction is happening, certainly on utilities that will be buried, we want to use as high of accuracy GPS devices as possible. So in terms of GPS devices with ESRI Field Maps, you can use any third-party GNSS that is compatible. For our clients collecting, many are using a brand new technology from Trimble called Catalyst. The receiver is the DA2. So Catalyst is a revolutionary new technology that acts as hardware as a service. We're all familiar with software as a service these days, but Catalyst brings hardware into that equation. In short, you now have the ability to purchase a high-accuracy GNSS receiver for a fraction of the price previously. Rather than pay an upfront charge of over $10,000, say for 1 to 2 centimeter accuracy, you can now purchase the receiver for under $500. You then turn on the level of accuracy that you need for the project. You can turn on the subscription. You can turn it on or off as needed in hourly, monthly, or yearly increments. And this is all on an as-needed basis. So the low cost of the hardware and project-based subscriptions has given engineering firms the ability to outfit multiple crews with devices and manage the subscriptions when needed. Many of our client partners are now gearing up to have a DA2 in every construction truck as a result. Another benefit of the Catalyst is the method for which it is getting high-accuracy GNSS. Rather than having to get real-time network subscription for each state and each user within that state, Catalyst runs in the Trimble Correction Hub. This is both VRS Now terrestrial-based RTN and satellite-based. What this means is that you no longer have to know if and when you are inside of a real-time network to get high-accuracy GNSS. The Trimble Corrections Hub works anywhere in the United States and most of the world. In other words, the user simply turns on the GPS device and they are high accuracy per the subscription that they ordered. This removes much of the complexity for the field user and further promotes large-scale deployments and the ability to collect as-built data on any site per the workflows that we have seen today.
Well, that's the end of our session. We hope you found it insightful. If you have any questions, we'll be on line for the next few minutes and you can ask us. Otherwise, you can contact us on the emails you see on this slide, Schnesk@Seiler-ds.com. You can also email Tom at tcrone@seilerinst.com. Before we go, we'd like to thank our sponsors, without whom this event would not be possible. So when you get a chance, if you see somebody from one of these fine establishments, go ahead and thank them for their sponsoring of this event. And with that, that's the end. We'll see you again shortly, I hope. And we'll be available for questions. Like I said, please contact us. Thank you very much. Have a great rest of the session. Bye-bye.